Okay. So we have the first question on heating boron with caustic potash. The pair of products formed are potassium metaborate with hydrogen, potassium borate with water, potassium boride with water, या borax plus dihydrogen. On heating the elemental boron with caustic potash, yani boron plus KOH, what would be the products? So here we have the reaction. Boron with KOH in aqueous solution gives you KBO2 with the release of dihydrogen. So here the KBO2 is named as potassium metaborate. Now, if you remember, H3BO3 was named as
ऑर्थोबोरिक एसिड
ऑर्थोबोरिक एसिड एंड ऑर्थो में से अगर वाटर को रिमूव कर दो तो we get what is ortho minus water called?
मेटा
Meta. So HBO2 would be called metaboric acid. तो ऑर्थोबोरिक एसिड के करस्पॉन्डिंग सॉल्ट को बोलेंगे ऑर्थोबोरेट एंड मेटाबोरिक एसिड के सॉल्ट को करस्पॉन्डिंगली बोलेंगे मेटाबोरेट. नाउ विद अ बेस ऑर्थोबोरेट obtain करना पॉसिबल नहीं है. Why we can't obtain orthoborate on reaction with the base?
Because it's an acid.
हाँ, it's an acid, that is correct. मतलब मैं बोल रहा हूँ इस एसिड का सॉल्ट क्यों नहीं बना on the reaction of boron with KOH? Why didn't we get orthoborate? Why we are getting metaborate? What is the basicity of orthoboric acid?
Monobasic.
It's a monobasic acid. So though there are 3 hydrogen in the formula, but they are non-ionizable. They are non-ionizable. इसीलिए यहाँ पर ऑर्थोबोरेट जैसा प्रोडक्ट बनना पॉसिबल नहीं है. But with HbO2, this H is replaceable and this is ionizable. That is why the corresponding product which we obtained on reaction of B and KOH is metaborate. Okay, so the answer will be option A, potassium metaborate and dihydrogen. What is not true about borax? First of all, tell me the formula of borax. Borax formula is
Na2B4O7.10H2.
Na2B4O7.10H2O. That's borax. So borax के लिए what is not true? Molecular formula is Na2B4O7.10H2O. Perfectly okay. That's correct. Crystalline borax contains tetranuclear units of B4O5 OH4 2 negative. Is this correct?
Yes.
Yes. What was the structure of this anion? What special thing was present in this structure?
Bob linkage.
Bob linkages. So the 4 boron atoms were joined via oxygen atom, and जो 2 boron atoms है internally was also joined via oxygen atom, and each boron was attached to each boron was attached to 4 OH groups. I'll show you the structure also, but this is a correct statement that is important. It hydrolyzes in water, giving alkaline solution. True or false?
True.
True, because Na2B4O7, it's a salt. और salt को जब water में dissolve करोगे तो on the product side you will get acid and a base. बोरॉन के related acid मिलेगा H3PO3 और सोडियम के related base मिलेगा NaOH. मतलब now this is a solution of a weak acid and a strong base, due to which this solution would be alkaline. It contains 4 Bob bonds. Now, obviously बात है कि अगर option A, B and C are true statements, so this can't be a true statement. तो answer तो है option D. Now, can you tell me how many Bob linkages were actually present?
5.
5. And here you go with the structure. Let me just erase this. Yes. So the 4 boron atoms 1, 2, 3 and 4 are joined via oxygen atom, creating 4 Bob linkages, and 2 of the boron atom is also joined by oxygen internally, creating a 5th BOB linkage. The total number of Bob bonds or Bob linkages are 5, and each boron is bonded to the 4 hydroxy groups. That's how we get the formula for this as Na2B4O5OH4 and dot 8H2O. This is a tetranuclear unit of the borax through which we can identify the structure. Now इस structure में और भी कुछ important concepts हैं जो मैंने बताए थे. बोरॉन को अगर आप देखोगे, in which there is an oxygen atom linked, is having 4 bonds associated with it. With 4 bonds, these 2 boron atoms would be sp3 hybridized, and this boron atom, which is not having a Bob linkage internally, is having only 3 bonds. मतलब ये जो 2 boron atoms हैं, they will be sp2 hybridized. मतलब point number 2, in borax का unit, the 2 boron atoms are sp3 and the other 2 boron atoms are sp2, because of which this particular structure is considered to be non-planar. Because though ही boron atom plane में है, other 2 boron atoms are not in the same plane, so it is non-planar. समझा? Is this clear? Please respond.
Yes, sir.
So the answer would be option D. The structure of diborane. Diborane structure is very, very important, and it is having a formula B2H6 with a special bond between the 2 boron atoms called banana bonds, also called
3 center 2 electron bonds.
3 center 2 electron bonds. Perfect. So now the structure of diborane contains 4 2 center 2 electron bonds and 2 3 center 2 electron bonds. Yeah, 2 and 4, 2 and 2, yeah, 4 and 4. So which would be the correct statement?
First option.
A.
First option. Here is the structure. The two boron atoms in diborane were joined by the bridge bonds. Now there are two bridge bonds which are actually three center two electron bonds. Funda क्या था? One of the vacant orbital of boron atom overlaps with the filled half-filled orbital of hydrogen and the half-filled orbital of the another boron atom. Matlab, there are three nuclei which are involved in the overlapping, but the number of electrons which are shared are only two. That is why it is called three center two electron bonds. And in the three dimension, it appears in the form of a banana shape. That is why famously they are also called banana bonds. And ये जो hydrogen atom है, these are called terminal bonds, which are the normal bonds. Normal bonds matlab two center, two electron bonds. So there are 1, 2, 3, and 4 two center, two electron, and two of them are three center, two electron bonds. The hybrid state of carbon in diamond, graphite, and fullerene are. What is the correct combination?
First option.
First option sp3, sp2, and sp2. Diamond is a covalent network in which each carbon is tetrahedrally bonded to four other carbon atoms. Hence, the hybridization state of this carbon is sp3. Graphite में we have a layer-like structure in which the sheets are joined by weak bonds. So ये weak bonds की वजह से they are basically having the delocalized electrons, and due to the delocalized electrons, it can have the conduction possible. So graphite is a good conductor of electricity, and diamond is a bad conductor of electricity. Fullerenes जो है, they are actually derived from the graphite only, and it has a soccer ball structure, and it was named as Buckminster fullerene. So since it is a derivative of graphite, the carbon here are sp2 hybridized only. So the hybrid state would be sp3 for diamond, graphite, and fullerenes have sp2. Which of the following statement about carbon allotropes is incorrect? First, C60 allotrope contains 12 pentagons and 20 hexagons. What is C60?
Buckminster fullerene.
Buckminster fullerene का ही formula है. And is it correct that it contains 12 pentagons and 20 hexagons?
No.
Then what would be correct? This was a structure. This is the 5-membered ring, and उसके बाजू में you can see the 6-membered rings. And the fact was the Buckminster fullerene have 12 5-membered rings and 26 membered rings. This is a correct statement. और इसके related बहुत बार question आ चुका है. Buckminster fullerene contains how many 5-membered and how many 6-membered ring? It is 12 and 20. 12 pentagons and 20 hexagons. 12 pentagons and 20 hexagons. Graphite is a non-crystalline structure.
No. It is crystalline.
It is crystalline. Graphite has carbon atoms arranged in large plates of rings of strongly bound carbon atoms with interplate bonds. Polate nahi, interplate bonds. Large plates of rings matlab layer wala structure of strongly bound carbon atoms मतलब within the plane जो within the layer है, the carbon atoms are joined in the rings and they are strong bonds because वो covalent bonds है. लेकिन लेयर के बीच में जो bonds हैं, they are weak pi bonds which are having delocalization of the electrons. So वो वाले जो bonds है which are present between the layers, they are called interplate bonds. और यहाँ पर specifically we can write with weak interplate bonds. ठीक है, तो ये स्टेटमेंट जो है वो ग्रेफाइट के स्ट्रक्चर को ही डिफाइन कर रहा है. It is having carbon atoms arranged in large plates of rings of strongly bound carbon atoms within the layer. Mind that. With interplate bonds मतलब प्लेट्स के बीच में जो बॉन्ड्स है वो वीक delocalized bonds जो है उनको interplate bonds बोल रहे हैं. So this is a correct statement. And graphite is thermodynamically more stable than diamond.
Yes.
Is correct. Matlab, for every element, if there are multiple allotropes, then one of the allotrope is thermodynamically most stable. So in considering the reactions, that particular form, allotropic form is considered. तो कार्बन के केस में ग्रेफाइट इज द स्टैंडर्ड फॉर्म व्हिच इज कंसीडर्ड इन द थर्मोडायनामिक रिएक्शंस. तो जब हम थर्मोडायनामिक्स पढ़ेंगे, दिस पॉइंट वुड बी वेरी इंपॉर्टेंट. तो ग्रेफाइट इज थर्मोडायनामिकली मोर स्टेबल देन डायमंड, करेक्ट है. अच्छा, अलोट्रोपिक फॉर्म्स ऑफ सल्फर में व्हिच इज द स्टेबल फॉर्म?
Black sulfur.
सल्फर में ब्लैक सल्फर नहीं था.
Sorry, that is phosphorus.
हाँ, that was phosphorus. So you gave the answer for phosphorus, where black phosphorus is thermodynamically more stable. Okay, sulfur. Rhombic, monoclinic, plastic. कौन सा?
Rhombic.
Rhombic. Rhombic is the most common form of sulfur which we will come across because it is thermodynamically most stable allotrope of sulfur. तो कार्बन का हो गया ग्रेफाइट, फॉस्फोरस के लिए ब्लैक फॉस्फोरस एंड सल्फर के लिए rhombic sulfur. This falls about carbon. It has crystalline as well as amorphous allotropes.
Yes.
Yes. Graphite, fullerene, and diamond. These are all crystalline allotropes. Amorphous mein, what are the examples? Sorry. Charcoal, lamp black, ये सारे जो allotropes है, they are amorphous in nature. Charcoal, lamp black, these are amorphous allotropes. Graphite, diamond, and fullerene are crystalline allotropes. So the fact is, carbon can have both type of allotropic forms possible. Correct hai. Can form pi bond with other carbon atoms.
Yes.
True.
Second period element has only the
Pi bonds.
p orbitals present, which can overlap with the other elements to form a p-pi bond. और इसके जो p-pi bonds होते हैं वो बाकी एलिमेंट्स के कंपैरिजन में स्ट्रांग होते हैं कि वीक होते हैं?
Strong.
स्ट्रांग होते हैं because of the smaller orbital and effective overlap with the other elements का p orbital, the p-pi bond over here is very strong. तो ये एक और एनोमलस बिहेवियर का पॉइंट है कि जो सेकेंड पीरियड का एलिमेंट है वो p-pi बॉन्ड काफी स्ट्रॉन्गर बना सकता है एज कंपेयर टू अदर एलिमेंट्स ऑफ द ग्रुप. So it can form a p-pi bond which is stronger than the other elements. It cannot form p-pi bond with atoms like nitrogen and oxygen. True या false?
False.
False. Because कार्बन सेकेंड पीरियड एलिमेंट्स के कोई भी एलिमेंट के साथ पाई बॉन्ड्स बना सकता है, स्पेसिफिकली नाइट्रोजन और ऑक्सीजन के साथ. जैसे कार्बन एंड नाइट्रोजन फॉर्म्स अ ट्रिपल बॉन्ड इन द साइनाइड. कार्बन एंड ऑक्सीजन फॉर्म्स अ डबल बॉन्ड इन द कार्बोनाइल कंपाउंड्स. एंड ये वाले जो पाई बॉन्ड्स है वो p ऑर्बिटल्स के ओवरलैप से बनते हैं. दैट इज व्हाई दे आर कॉल्ड p pi bonds. P60 is an allotrope of carbon. Yes. So the correct answer is option C. Alumina can be converted to anhydrous AlCl3 by heating alumina with chlorine gas, with HCl gas, with NaCl in solid state, or a mixture of alumina and carbon and dry chlorine gas. Alumina to anhydrous AlCl3.
D.
Last option.
B is not correct. Last option is correct. यहाँ पर alumina and carbon, the carbon basically behaves as a
Reducing agent.
reducing agent. It takes away the oxygen of alumina, and then this aluminium combines with the chlorine to form AlCl3. So यहाँ पर this is the reaction. Alumina with carbon and Cl2 at a high temperature of 1000 degrees Celsius gives you AlCl3 plus carbon monoxide. So यहाँ पर function of carbon is very important, that it is taking away the oxygen of alumina to convert to Al, and that combines with the chlorine to form the AlCl3. This is one of the extraction related reaction also, जहाँ पर alumina can be reduced to Al and then further added with chlorine to form the vapors. And this will be in anhydrous form. That is why it is anhydrous AlCl3, which is formed in the reaction. The order of acidic strength of boron 3 halides is. बोरॉन के हैलाइड्स का एसिडिक स्ट्रेंथ इज फॉलोइंग व्हिच ऑर्डर? वेरी इंपॉर्टेंट क्वेश्चन. Should be known.
First option.
First option. And what was the main reason behind that?
The back bonding amount is lesser as you go down the group.
Very good.
Halogens.
Yes. So boron के halides में, first of all, if I represent the structure as BF3, then this particular boron atom, because of the sp2 hybridization, has one of the p orbital which is vacant, and the bonded atoms, that is fluorine or any other halogen, have the lone pairs which can be donated into the vacant p orbital. तो जब bonded atom का lone pair vacant orbital को donate होता है, that particular bonding is called back bonding. And this back bonding creates a lateral overlap. That is why it is called p pi back bonding, because p orbital of boron and p orbital of fluorine are involved in the back bonding. Hence it is p pi back bonding. अब यहाँ पर because boron and fluorine are both placed in the second period, the p pi back bonding is very efficient, and that is the reason boron here becomes less electron deficient. And अगर वो less electron deficient है, तो its tendency to accept an electron pair or its tendency to act as a Lewis acid would be lesser. That is why BF3 सबसे वीक एसिड है, वीक ल्यूइस एसिड है बोरॉन के हैलाइड्स में। अब जैसे जैसे यहाँ पर फ्लोरीन की जगह क्लोरीन, ब्रोमीन एंड आयोडीन आते जाएगा, द p ऑर्बिटल विल बिकम लार्जर एंड लार्जर। लेकिन जो b का वीकेंड p ऑर्बिटल है वो तो फिक्स ही है। अब जैसे मैं आयोडीन की अगर बात करूं तो दिस इज हाउ द p ऑर्बिटल ऑफ आयोडीन विल लुक लाइक। अब ये छोटा सा ऑर्बिटल और ये ह्यूज p ऑर्बिटल के बीच में द ऑर्बिटल ओवरलैपिंग इज नॉट गोइंग टू बी दैट एफिशिएंट, and that's why the Bi3 will act as a very good acid, and that's why the answer is A. Clear? अच्छा, अब इसके कुछ और facts. So when it forms a lateral overlap, it creates a pi bond between the boron and the fluorine atom. So based on that, if they ask you the bond order of boron fluorine bond in BF3, what would be the answer? Bond order.
1 plus 1 by 3.
1 sigma and 1 pi divided into 3 positions, which is equal to 4 by 3 या 1.33. Very important point for the bond order of boron halides. ठीक है? और एक चीज, if they ask you the boron का halides का acidic strength compared with the other element का halides, AlCl3, GaCl3, InCl3. What is the order now among the elements of group 13 down the group? In the previous case, the central atom was fixed and the bonded atom was differing. Now the bonded atom is fixed and the central atom is differing. Is case mein what was the order?
Decreasing down the group.
Pardon?
Boron is the highest.
Yeah. Down the group it decreases. Boron ka trihalide among the other halides is a stronger Lewis acid. So these are the two orders for the acidic strength of boron halides. Very, very important. Okay, so with the MCQ itself, I am discussing all the other important related points which could be asked. मतलब ये एक हो गया, that is the order of the acidic strength. Secondly, the effective p-pi back bonding will happen in boron and fluorine atoms. Then based on the p-pi back bonding, with the formation of pi bond, the bond order becomes 1.33 or 4 by 3. Okay. And then the fourth one could be the acidic strength for the central atom differing for the halides of the group 13. Okay, so do MCQ in such a way that all the associated concepts and the points are also covered. आप एक MCQ के साथ साथ जितने भी और रिलेटेड पॉइंट्स है वो कवर करने का ट्राई करो, तो आपका एक ही MCQ के साथ मल्टीपल MCQs कैन बी कवर्ड। आपको और मल्टीपल MCQ सॉल्व करने की जरूरत नहीं पड़नी चाहिए। A metal M forms a chloride in +2 and +4 oxidation states. Which of the following statement about these chlorides is correct? +2 and +4 में chlorides बना रहा है. Which is correct statement? MCl2, meaning the element M in the +2 is more volatile than the metal M in the +4. Yeah, MCl2 is more soluble in anhydrous ethanol than MCl4, is more ionic, or is more easily hydrolyzed. How do you decide? Yes. How will you decide onto these properties? Concept
Chance
you
rule.
need to think. Fajan's rule. So tell me, for Fajan's rule, a compound will have high covalent character with what conditions?
High positive charge.
High positive charge or
Small cation, large anion.
yes. Small cation, large anion, high positive charge are the three factors by which we can decide whether a compound has high covalent character or not. Now tell me, MCl2 versus MCl4, which satisfies for the covalent character?
MCl4.
MCl4. Matlab, this particular compound in the high oxidation state with a smaller cation and anion remaining same is more covalent than this. So I can consider MCl2 to be ionic than MCl4. So which could be the correct statement?
C.
C.
C. ठीक है, correct statement तो मिल गया. अब a compound which is covalent, will it have a high boiling point or low boiling point?
Low boiling.
Low.
Low boiling point. Covalent compounds have a low boiling point. So if it is having a low boiling point, will it be more volatile or less volatile?
More volatile.
More volatile. ठीक है, तो MCl2 more volatile होना चाहिए, not MCl2, तो ये गया. Covalent compound है, तो will it be soluble in polar या non-polar solvents? Covalent compound will be soluble in polar या non-polar solvent?
Non-polar.
Non-polar. तो MCl4 जो covalent है, it will be more soluble in the anhydrous ethanol than MCl4. That is incorrect. MCl4 ज्यादा soluble होगा, तो ये option भी ruled out. And among the ionic versus covalent compound, which is more easily hydrolyzed?
Ionic.
नहीं.
Covalent compound.
मुझे बताओ, लिथियम फैमिली में जब हम लिथियम क्लोराइड से सीजियम क्लोराइड की तरफ जाते थे, which had the highest enthalpy of hydration?
Lithium chloride.
Lithium, because of its
High positive charge.
नहीं नहीं नहीं, यहाँ पे पॉजिटिव चार्ज तो
Small
सेम ही है ना.
size.
हाँ, because of the small size. तो ध्यान रखना, a compound which is covalent will be more easily hydrolyzed. Ionic compounds are not that easily hydrolyzed because M और Cl का यहाँ पर जो bond बनता है covalent compounds में, that is easy to break down by the water, and because of the smaller size the cation could be easily hydrolyzed. Remember, covalent compounds are more easily hydrolyzed. और ये रटना नहीं है, हमने लिथियम के फैमिली के लिए देख लिया है, बेरिलियम हैलाइड्स के लिए भी देखा है कि बेरिलियम में हाइड्रेशन सबसे ज्यादा होता है एज कंपेयर टू बेरियम. So we can now confirm that the covalent compounds are more easily hydrolyzed. तो ये भी statement wrong है. तो एक ही correct था, that's option C. Have a look at this. As per Fajan's rule, a compound having small cation, large anion, and a high positive charge has high covalent character, low boiling point, hence it is more volatile, is soluble in non-polar solvents, and will be more easily hydrolyzed. मतलब just covalent character के साथ साथ we can understand that the compound has a low boiling point and is more volatile, is soluble in non-polar solvents, and will be more easily hydrolyzed. Everything gets covered with this. Diborane reacts independently with oxygen and water to produce which compounds? Diborane with oxygen gives what?
2O3.
Yes. Boron over here burns in oxygen to form its oxide, and boron ka oxide is B2O3. This was also named as something. इसका एक और
Boric
नाम,
anhydride.
boric anhydride, which is a constituent of one very important test, which is the constituent of a very important test,
Borax speed test.
borax bead test. Borax bead test, that is very important. The boric anhydride B2O3 is important for the borax bead test. B2O3 तो आ गया, मतलब ऑप्शन सी एंड डी तो रूल आउट हो गए. अब डाइबोरेन जब वाटर के साथ रिएक्ट करेगा तो विच वुड बी द करेक्ट प्रोडक्ट आउट ऑफ ऑप्शन ए एंड बी?
A.
A. So the boron takes away the hydroxy groups of water and it forms H3BO3 orthoboric acid, and there is a release of dihydrogen. Remember, with B2H6 on hydrolysis, boron and the OH combines to form the acid and the hydrogens would release the dihydrogen gas. So ये भी पूछा जा सकता है कि B2H6 का hydrolysis होने पर which gas is released या how many moles of hydrogen is released. तो variety of questions यहाँ पर आ सकते हैं. Answer is A. Which of the following is amorphous form of silica?
D.
Last.
D. That is Kieselguhr. Now this is a factual statement, and in fact CQT, that is cristobalite, quartz and tridymite are the crystalline forms of silica, but the amorphous form में एक important नाम है, and that is Kieselguhr. Kieselguhr is amorphous form. Which of the following anions is present in single chain silicates? Zeolites, feldspar, mica, these are different forms of the silicates. Or silicates where we can have multiple type of silicates which are possible. Single chain, double chain, pyrosilicates and so on. तो single chain silicates का जो anion है, that is SiO3 2 negative. Single chain silicates is SiO3 2 negative. ये वाला जो है, this is the normal silicate, and this is the main anion which is present in most of the silicates. The building block of the silicates is SiO4 4 negative, which is having a tetrahedral arrangement of one silicon surrounded with 4 oxygen atoms, with each oxygen bearing a negative charge. तो ये है SiO4 4 negative. ठीक है? Si2O72 negative is a pyrosilicate which is having SiO-Si वाला linkage. तो एक ऑक्सीजन एटम दो सिलिकेट्स के बीच में जब होगा, that would be a pyrosilicate. These are some important points to be remembered from the silicates part. Which of the following oxidation states are most characteristic for lead and tin? How you decide the oxidation state which is stable for a given element? Inert pair effect. तो बड़े के लिए छोटा, छोटे के लिए बड़ा, oxidation state is always more stable. So tell me, for lead and tin, what would be the characteristic oxidation states?
C.
C. Yes. Now lead and tin दोनों ही heavier elements हैं. उसके basis पे आप सोचो तो it should be the two oxidation state which is more stable. But ऐसा नहीं था. Lead और tin में lead has the oxidation state of +2 which is lead will have the oxidation state of +4 which is more stable, and tin जो कि बड़ा element है उसके लिए छोटा oxidation state of +2 would be more feasible. Sorry, my mistake. Tin and lead is arranged in this order. So lead जो है that will have the oxidation state of +2 possible, and tin के लिए the oxidation state of +4 was more feasible. So tin के most of the stable compounds are in the +4 oxidation state. Sorry, and lead has the stable compounds in the +2 oxidation states. Which of the following is correct? Boric acid is a protonic acid. True या false?
False.
What was the fact related with this statement? If you say false, why it is not a protonic acid?
It is
Makes
a
the pro
weak monobase.
It is a
Weak monobasic acid, so it does not release H plus easily.
does not release H plus, that is correct, but does not release H plus on its own. Boric acid H plus खुद से नहीं निकालता. In fact, what happens is, here since the boron is electron deficient, when the orthoboric acid is dissolved in water, it accepts an electron pair from the oxygen of water to convert into a complex ion BOH4 negative with its max coordination number of 4, and thereby releases the H plus ion. So this H plus ion which is released is not released from the orthoboric acid, it is released from the water. Clear? That is why we say orthoboric acid is not a protonic acid, because it does not release H plus ion on its own, and on dissolution in water it releases only one H plus ion. That is why it is a weak monobasic acid. ये correct statement नहीं है. Beryllium exhibits coordination number of 6. Second period elements can have its max coordination number equal to
4.
4. It can't expand its octet because of the absence of the
Vacant orbit.
vacant d orbital. तो बेरिलियम, बोरॉन, कार्बन, ये सारे जो एलिमेंट्स हैं उनका मैक्स कोऑर्डिनेशन नंबर 4 ही होता है, या कोवेलेंस जो है वो 4 ही होता है. Chlorides of both beryllium and aluminium have a bridged structure in solid state. How does BeCl2 exist in the solid state?
Monomer.
In the solid state, it exists as a monomer. Nahi. In solid state, it is more associated. It exists as a polymer, where the beryllium atoms are joined by the chlorine atom as a bridge. So that has a bridge structure. Or AlCl3 exists as a dimer, जिसमें again the chlorine atom acts as a bridge between the aluminium atoms. तो ये statement correct है. Answer is C. Chlorides of both beryllium and aluminium have a bridge structure in solid state, and the bridge bond over here is not a banana bond, it is a two center 2 electron bond. It's a normal coordinate covalent bond. The number of isomers possible for a di-substituted borosine is 3. Now this is a false statement. अब ध्यान से सुनना इस बात को, it's important. First of all, this is your BeCl2 in the solid state, which has a bridged structure, and the chlorine over here forms a bridge with a two-centered 2-electron bond. This is for AlCl3 existing as a dimer in the solid state, and here we have borosine. How is borosine formed? Borosine का preparation method क्या था? Quick.
Diborane with ammonia.
Borane plus ammonia.
Diborane, when reacts with ammonia, it forms a borosine compound, which is also called
Inorganic benzene.
inorganic benzene or borazole. And the molecular formula of that is B3N3H6. जहाँ पर boron and nitrogen are alternately arranged, joined by single and double alternate bonds, and each boron and nitrogen is bonded to hydrogen. That's how it resembles benzene, and it's called inorganic benzene. अब यहाँ पर 4 isomers possible है, because disubstituted का मतलब 2 of the hydrogen are to be replaced by the substituents. So it can have the substituent at the NB position, NN position meaning meta, and N or B ka position, that is para. Matlab, if the substitution is done at this position with starting from boron, it will have the ortho at Bn, meta at Bb, and para at Bn. Correct. लेकिन अगर आप ऑल्टरनेट अरेंजमेंट्स को देखो तो उसमें ऑल्टरनेट एटम्स अलग है. तो मेटा पोजीशन अगर आप ऑब्जर्व करोगे तो हियर दिस टू सब्स्टिट्यूएंट्स आर एट द नाइट्रोजन एटम्स, बट इट कैन आल्सो बी एट द बोरॉन एटम्स. बाकी एडजेसेंट में हमेशा Bn पे ही होगा और ऑपोजिट में भी वो Bn पे ही होगा. लेकिन मेटा में या तो वो Bb पे हो सकता है या फिर Nn पे हो सकता है, लाइक दिस, ये वाला या ये वाला, right? So number of di-substituted isomers of borazole is not 3, it is 4. लेकिन बेंजीन में वही di-substituted isomers 3 ही आ सकते हैं क्योंकि सारे एटम्स सिमिलर है. Benzene have 3 isomers, but borazine have 4 isomers because the alternate arrangement have different atoms. Clear? Yes or no?
Yes, sir.
Hello.
Clear, sir.
Among the following substituted silanes, the one which will give rise to a cross-linked silicon polymer on hydrolysis is, cross-linking आने के लिए कौन सा क्लोरोसिलेन यूज करना होगा?
B.
B. जो नॉर्मल सिलिकॉन्स बनते हैं, they are formed via R2SiCl2, which is hydrophobic in nature, water repellent property होती है इसकी. तो उसमें एक लीनियर सिलिकॉन बनता है बिकॉज ऑफ द 2 हाइड्रोक्सी ग्रुप्स. इसको जब हाइड्रोलाइज करोगे तो आपके पास 2 OH आएंगे. लेकिन अगर क्रॉस लिंकिंग करना है, मतलब बिटवीन द सिलिकॉन्स, इफ यू वांट टू हैव द अरेंजमेंट, देन वी नीड टू हैव 2 क्लोरीन्स लाइक दिस, सॉरी 3 क्लोरीन्स. तो 3 क्लोरीन्स में क्या होगा? वी विल हैव 3 OH ग्रुप्स. अब जब इसका पॉलीमराइजेशन करोगे, you will have SiO-Si linkage in the linear chain and the OH groups, because it is present above that, it will also form the SiO-Si linkage above and below. So this linkage which is formed between the layers is called cross-linking. Hence cross-linked polymer होने के लिए the substituted silane should be RSiCl3. In the context of Hall-Héroult process for the extraction of aluminium, which of the following is not correct? This is a question from the metallurgy chapter. Metallurgy अभी हुआ नहीं है, तो as of now इसको skip कर सकते हो. But the correct statement, if you remember the Bayer's process well, then Na3AlF6 serving as the electrolyte is not correct. The alumina mixed with calcium fluoride and cryolite was used in the Bayer's process for the extraction. तो electrolyte Na3AlF6 नहीं behave करता है. इनफैक्ट alumina के साथ CaF2 को mix किया जाता है for lowering the melting point of alumina and increasing the conductivity. And क्योंकि alumina is the electrolyte, the Al3 plus ion is reduced to aluminium at the cathode, and this is how the aluminium gets extracted by electrolytic process. And graphite के electrodes use किए जाते हैं जो oxidize होकर कार्बन मोनोऑक्साइड और कार्बन डाइऑक्साइड प्रोड्यूस करते हैं. ठीक है, so don't worry about this question if you are not comfortable as of now, because metallurgy हो जाएगा तो you will be able to understand this. Which of the following species are not known? Should be simple.
B.
B. And why? See, boron as a second period element can have a max coordination number of 4. So ये species तो definitely correct है. बाकी elements in the third period or onwards can have a coordination number 6 possible. तो silicon के लिए SiF6 2 negative anion possible है. Theoretically, B and D should also be the correct options. But silicon, because it's a smaller atom, will not be able to hold 6 chlorine atoms. And that is why Si के साथ F6 बन सकता है, but Si के साथ Cl6 will not be known, meaning it doesn't exist practically. But lead, जैसे जैसे size बढ़ेगा, will be able to hold 6 chlorine atoms, and this species will be possible and existent. The answer is B. This is how you think about it. The correct statement about orthoboric acid is R. It behaves as a weak acid in water due to self-ionization. True or false? Quickly answer.
False.
Because self-ionization वो करता ही नहीं है. It is not a protonic acid because it does not give the H plus ion on its own. तो ये false हो गया. Acidity of its aqueous solution increases upon addition of ethylene glycol. Okay, I'll discuss this. It has a three-dimensional structure due to H bonding. How was the structure of orthoboric acid? Was it 3D or 2D?
2D.
It was a planar two-dimensional structure where the molecules were joined by H bonds. Three-dimensional नहीं है. Three-dimensional होता तो sp3 hybridized या कोई और होना चाहिए था. यहाँ पर the boron has sp2, मतलब all the atoms are in the same plane. It's a planar two-dimensional structure. It is a weak electrolyte in water. Okay, no, yeah. So here are the 4 points. H3BO3 is a weak monobasic Lewis acid. That is already discussed. Key, it will take away the lone pair from the oxygen of water and form the BOH4 negative along with giving the H plus ions from the water, not of its own. Equilibrium in the above reaction is shifted in the forward direction by addition of syn diols like glycol, which forms a stable complex with the BOH4 negative. तो ये जो BOH4 है उसके साथ when we add the ethylene glycol, It forms a cyclic structure like this, due to which the equilibrium shifts on the right hand side, and अगर right side पे shift हो गया, इसका मतलब it will have more of the solubility in the glycol. It has a planar sheet-like structure due to hydrogen bonding and not has a three-dimensional structure. And it's a weak electrolyte in water, yes. यहाँ पर करेक्ट स्टेटमेंट ऑप्शन बी और ऑप्शन डी दोनों है. सॉरी, ऑप्शन डी में एक मिनट वहां पर क्या, अच्छा दिस वाज प्रॉब्लम. यहाँ पर क्वेश्चन में स्ट्रॉन्ग दिया हुआ है जो कि इनकरेक्ट हो जाएगा. दैट्स व्हाई नाउ द आंसर व्हिच वी गेट इज ओनली ऑप्शन बी. In the compound of type ECl3, where E is boron, phosphorus, arsenic or bismuth, the angle CLE Cl, मतलब bond angle, different element are in the order. So tell me, how would you compare the bond angle for BCl3, ECl3, ASCl3 and BiCl3? What will you think?
Hybridization.
Hybridization. And hybridization के लिए you always apply the VSEPR theory. So central atom is boron having 3 electrons and they are bonded to chlorine. Matlab there are 3 BPs, no LP. With 3 BPs, the hybridization will be sp2. The geometry would be planar and the bond angle would be 120 degree. Phosphorus के लिए there are 5 electrons in the valence shell, 3 gone. So 1 will act as a lone pair. Matlab there are 3 BPs, 1 LP. The hybridization is sp3 and it is distorted called pyramid with an angle of less than 109 degree, 28 minutes. And उसी family में arsenic और bismuth का chloride down the group will have an angle decreasing or increasing?
Decreasing.
Decreasing. So अब क्लियर है कि BCl3 का बॉन्ड एंगल सबसे ज्यादा होगा बिकॉज वो sp2 हाइब्रिडाइज्ड है और बाकी 3 कंपाउंड्स में डाउन द ग्रुप डिक्रीज होगा. सो द करेक्ट आंसर इज ऑप्शन बी. मतलब बॉन्ड एंगल रिलेटेड क्वेश्चंस आर टू बी सॉल्व्ड बाय थिंकिंग अबाउट हाइब्रिडाइजेशन and getting the geometry and the bond angle via that. Which of the following set contains only amphoteric oxides? Should be simple.
A.
It is A, zinc, aluminium, lead and tin. Zinc, aluminium, lead and tin are amphoteric oxides. Now moving on to the unit 7 of 12th one, which is P block covering group 15 to 18. First, the reaction of white phosphorus with aqueous NaOH gives phosphine and another phosphorus containing compound. The reaction type, oxidation state of phosphorus in phosphine and other products are respectively. Quickly answer.
C.
It's not A. When you have redox and disproportionation given, this reaction of phosphorus and NaOH was a special redox called. See, in the revision session, I should not speak much. Revision में आपको बोलना चाहिए. So this reaction of phosphorus with alkali is a disproportionation reaction where phosphorus with alkali gives phosphine and NaH2PO2, sodium hypophosphite. So here the zero oxidation state is reduced to -3 and oxidized to +1. So it's a disproportionation reaction with the oxidation state of phosphine as -3 and other phosphorus containing compound is +1. Sorry, the answer will be C, not D. अब जैसे ही हम डिस्प्रपोर्शनेशन सोचते हैं, मैंने एक ट्रिक दिया था कि फॉस्फोरस के अलावा थर्ड पीरियड का एलिमेंट that is sulfur and chlorine on reaction with NaOH also undergoes the disproportionation reaction. अब सल्फर के केस में it gives you sulfide and sulfide and sulfide with water on the right side. और क्लोरीन के साथ NaOH के दो केसेस थे. In the cold condition it forms NaCl and NaOCl hypochlorite with H2O. एंड हॉट कॉन्सेंट्रेटेड NaOH के लिए इसी रिएक्शन में आगे क्या होता है, इंस्टेड ऑफ द हाइपोक्लोराइड यू गेट द क्लोरेट एंड वाटर एंड देन ऑक्सीडेशन स्टेट बैलेंसिंग. ये सब के क्वेश्चंस आ सकते हैं. बट द मोमेंट यू थिंक अबाउट phosphorus and alkali, I had given a statement that third period elements of group number 15, 16, 17 on reaction with NaOH always undergoes a disproportionation reaction. And these are the 4 disproportionation reactions which are important. And one more thing, when chlorine is treated with calcium hydroxide, which is dry slaked lime, it forms
Bleaching powder.
bleaching powder, that is having a formula CaOCl2. और ब्लीचिंग पाउडर में खास बात था कि the two chlorine atom exist in the oxidation state of -1 and +1. So that covers all the important concepts related with the disproportionation reaction and the reaction of alkali. Which of the following are correct about zinc, cadmium, mercury? Statements दिए हैं. Let's see. They exhibit high enthalpy of atomization as the D subshell is full. True or false?
False.
False. Because zinc, cadmium, and mercury, because of the D10 configuration, have the lowest enthalpy of atomization. In fact, among the 3D series element, the highest enthalpy of atomization was for which element? Should be known.
Vanadium.
Vanadium. Highest enthalpy of atomization is for vanadium and it depends on the number of unpaired electron. So theoretically, इसमें chromium and manganese should have been the probable options, but because of the stable half-filled configuration, the enthalpy of atomization is exceptionally lower. तो highest किसको जाता है, बस याद रखो, that's vanadium. Next, zinc, cadmium do not show variable oxidation state, whereas mercury can show +1 and +2. True or false?
True.
True.
True. Compounds of zinc, cadmium, and mercury are paramagnetic.
No.
They can't be. Zinc and cadmium के लिए तो D10 configuration आता है और ये एक ही oxidation state बताता है, तो इनमें तो diamagnetic ही होगा. Mercury के केस में when it is +2 it's dia, when it is +1 it can be para, but in general इन तीनों के compounds paramagnetic है, that is false. They are soft metals.
True.
True, they are soft metals with a low boiling point. So the correct statements would be 2 and 4. Oxo anion, which contains all equivalent MO bond, metal oxygen equivalent bonds. First one is chromate, next is permanganate, and then dichromate.
Only 1 and 2.
only 1 and 2. The problem with the third one is it has a CR O CR linkage with each chromium bonded to 3 oxygen on either sides. तो यहाँ पर जो टर्मिनल वाले क्रोमियम ऑक्सीजन बॉन्ड्स है दे विल बी ऑफ इक्वल लेंथ, बट ये वाले जो CRO बॉन्ड्स है दे विल हैव अ डिफरेंट बॉन्ड लेंथ. दैट इज व्हाई all the CRO bonds are not equivalent, and here the angle of CRO CR bond was
126.
126 डिग्री. ये भी पूछा जा सकता है. तो इसमें दो टाइप के CRO बॉन्ड्स रहेंगे. टर्मिनल वाले 6 इक्वल होंगे और बीच वाले 2 बॉन्ड्स अनइक्वल होंगे एज कंपेयर्ड विद अदर्स. In context with transition elements, the D block, which of the following statement is incorrect? In addition to the normal oxidation states, the zero oxidation state is also shown by these elements in complexes.
Yes.
True or false?
True.
Yes, कार्बोनाइल कॉम्प्लेक्सेस जीरो ऑक्सीडेशन स्टेट या इवन नेगेटिव में बन सकते हैं. मतलब ये स्टेटमेंट करेक्ट है. In the highest oxidation state, the transition metals show basic character and form cationic complexes.
False.
False. Now इसमें if you remember, मैंगनीज के मल्टीपल ऑक्साइड्स थे. MnO, MnO2, rather Mn2O3, then MnO2 and Mn2O7. तो अगर मल्टीपल ऑक्साइड्स है तो उसमें हाउ डू यू डिसाइड द नेचर ऑफ द ऑक्साइड? व्हाट वाज द ट्रिक? What was the trick?
Higher oxidation state will be acidic.
Highest oxidation state would be acidic, lowest would be basic, and generally middle oxidation states जो होते हैं वो amphoteric होते हैं. ठीक है, तो this is a general rule to remember. तो ऑप्शन बी उसके बेसिस पे इनकरेक्ट हो जाएगा. In the highest oxidation state of the first 5 transition elements, cadmium to manganese, all the 4s and 3d electrons are used for bonding.
True.
True, because उसमें सारे electrons unpaired होते हैं, तो unpaired होंगे तो they will be available for bonding. And once the d5 configuration is exceeded, the tendency to involve all the 3d electrons in bonding decreases, because वहां पर pairing शुरू हो जाता है तो सारे d electrons involve नहीं हो सकते हैं. So the incorrect statement was option B. Pair of ions having same number of unpaired electrons. Now, how do you get to the configuration for the ions given? So first of all, if you look at the options, they are the ions of which series? Lanthanoids. And can you quickly tell me the elements? Yes, anyone?
Lanthanum,
Hmm.
cerium,
Hmm.
praseodymium,
Hmm.
neodymium,
Hmm.
promethium,
Yes.
samarium,
Samarium.
europium, gadolinium, terbium, dysprosium,
Last. Hmm.
chromium, erbium,
thulium, ytterbium, and lutetium. So simple trick to remember was LCP, living certificate presented, no positive solution, European government. 2, do homework, error free. 2, yield love. Now इसमें यूरोपियम और टर्बियम का कॉम्बिनेशन दिया हुआ है which is placed above and below the reference gadolinium. Why I say gadolinium is a reference? Because it is beach wala element. And when you say beach wala element, it will have F with how many electrons?
7.
7.
तो इसका कॉन्फ़िगरेशन तो आपको याद हो जाना चाहिए, that is 4f7. इसमें 5d में इलेक्ट्रॉन था कि नहीं था?
It was there.
It was there. In fact, it was there for which all elements?
Cerium, gadolinium, and lutetium.
Na. 5d electron was not present in cerium. पहला बीच का आखिरी का. अब सीरियम में एक्चुअली एनसीईआरटी में दिया हुआ है, इसीलिए हम कंसीडर करते हैं, बट एक्चुअल में द 3 एलिमेंट्स व्हिच हैव द डी इलेक्ट्रॉन प्रेजेंट इन इट इज पहला, बीच का एंड आखिरी का. तो एज ऑफ नाउ आप ध्यान रखो कि लैंथनम, गैडोलिनियम एंड लुटेशियम में है. ठीक है, तो 5d का एक इलेक्ट्रॉन यहाँ पर होगा एंड 6s तो कंप्लीटली फिल्ड होता है. Up when I take the +3 configuration, the 3 electrons will be removed from here and the gadolinium ka 3 plus will have 4f7 configuration. अब with reference to that, यूरोपियम में configuration क्या होगा? एक इलेक्ट्रॉन कम.
4f7, 6s2.
4f7, 5d0 and 6s2. अब इसमें से 3 इलेक्ट्रॉन निकालोगे तो यूरोपियम 3 plus will have.
4f6.
Then terbium.
4f9, 6s2.
4f9, 5d में कोई इलेक्ट्रॉन नहीं, 6s2. अब इसका जब 2 इलेक्ट्रॉन जाएगा तो मिलेगा टर्बियम 3 plus with 4f8. Now with 4f6, how many electrons are unpaired?
6.
All. And 4f8 में एक इलेक्ट्रॉन पेयर हो जाएगा तो number of unpaired electrons would be
7. 6.
6, ना? One electron will enter as a single and then 8th pair हो जाएगा तो 6 ही unpaired मिलेंगे. मतलब यूरोपियम का 3 plus and टर्बियम का 3 plus have the same number of unpaired electron. Correct answer is option A. Likewise, बाकी का भी आप find out कर सकते हो, खाली reference को याद रखो. लैंथनम 4f0 होता है, 5d1 6s2. गैडोलिनियम लास्ट वाला जो है वो 4f7 5d1 और 6s2 होता है. Cerium is an important member of lanthanides, which is correct statement about it. The +3 oxidation state of cerium is more stable than the +4 oxidation state. Now, if you remember, lanthanides mein common oxidation state was, I want an
+3.
answer from you all, +3. Apart from +3, it can show
+4 and +2.
+4 and +2. A +2 is shown by which elements? Remembered as
Set Y.
set Y. +2 is shown by set Y and +4 is shown by
PTD.
cool place to dance, CPTD. So now if you fill up the symbols, this is samarium, europium. What is this T? Thulium or terbium?
Thulium.
Thulium, ytterbium. and this will be cerium, praseodymium, terbium and dysprosium. हो गया. तो सीरियम के लिए +4 ऑक्सीडेशन स्टेट एग्जिस्ट करता है, बट सोल्यूशन में अगर बात करें तो +3 will be more stable, because if you remember the +4 will try to come back to its +3 common oxidation state. In that process it will undergo reduction,
Reduction.
and that's why these ions will act as good
Oxidation.
oxidizing agents. So this will be a correct statement. The common oxidation states of cerium are +3 and +4. Yes, they are. Cerium 4 acts as an oxidizing agent.
Yes.
Yes.
It does. And the +4 oxidation state of cerium is not known in solutions. It is definitely known. So the correct answer is D. समझा?
Yes, sir.
Which of the following contains POP bond? POP linkage किसमें है?
C.
C. Pyrophosphoric acid. Now pyrophosphoric acid का फॉर्मूला कैसे डिराइव करना है उसका ट्रिक दिया था मैंने. So for that you write ortho वाला formula, and then what was the trick to get the pyro acid का formula?
2 ortho minus 1 water.
Double the ortho and remove one water. Excellent. Twice the ortho minus water is pyro acid. So जब आप इसको twice करते हो तो आपको मिलता है H6P2OH. पानी निकालोगे तो H4P2O7. ये हो गया फॉर्मूला. अब स्ट्रक्चर ड्रॉ करने के लिए व्हाट इज द फर्स्ट थिंग यू शुड स्टार्ट विथ?
POP linkage.
POP linkage. Then in all the oxo acids of phosphorus there was something common.
Double bond O.
Double bond O and
OH.
OH. Each phosphorus is sp3 with one double bond O and OH present. Up satisfying the formula, you get the OH groups over here. So it becomes a tetra basic acid with a POP linkage. That's the pyro का formula, structure and the important details. बस इसी type के questions आते हैं oxy acids में से. By the way, hypophosphorus acid is nothing but H3PO2, which is a monobasic acid, has only one POH. Phosphorus या orthophosphorus is H3PO3, which is a dibasic acid, has only two POH bonds. And orthophosphoric acid में सारे POH bonds होते हैं, मतलब there are 3 POH bonds and it's a tribasic acid. Which of the following reactions of xenon compounds is not feasible? Xenon trioxide with HF gives you XeF6 and water. Xenon का tetrafluoride on hydrolysis, xenon का difluoride on hydrolysis, and xenon hexafluoride with metallic fluoride. Achha, can you tell me which reactions are known to you?
B, C.
B and C. और हाइड्रोलिसिस का एक ट्रिक बताया था कि अगर XeF4 का हाइड्रोलिसिस करना है तो दो तरह के हो सकते हैं. One is partial and other is complete. Partial and complete. अगर आप इसमें पार्शियल हाइड्रोलिसिस करते हो तो जितने हाइड्रोजन उतने फ्लोरीन के साथ HF बना दो 2HF, एंड देन जो भी बचा उसका मेन प्रोडक्ट पता चल जाएगा XeOF2. वैसे ही अगर यहाँ पर आप कंसिडर करोगे यू गेट 4HF and XeO2, बट प्रॉब्लम यहाँ पर था कि जेनॉन में डाई ऑक्साइड जैसा कोई भी ऑक्साइड नहीं बनता है, तो ये यहाँ पर होगा डिस्प्रपोर्शनेट, और डिस्प्रपोर्शनेट होगा तो जेनॉन मिलेगा, जेनॉन का ट्राई ऑक्साइड मिलेगा, एंड देयर विल आल्सो बी द ऑक्सीजन गैस. So based on that, the xenon tetrafluoride का hydrolysis gives you Xc, XCO3, oxygen and HF. This is definitely a correct reaction. And XeF2 के लिए अगेन यहाँ पर क्या होगा, अगर आप करोगे रिएक्शन तो XeF2 plus H2O, जितने H उतने F को निकाल दो, एंड वापस यहाँ पर XeO टाइप का ऑक्साइड मिलता है जो कि नोन नहीं है, ये ब्रेक डाउन होगा into Xe and O2. So this will also be the correct and a feasible reaction. एंड लास्ट रिएक्शन अगर देखोगे ये भी feasible है, because xenon hexafluoride जो है, whenever it reacts with a metallic fluoride, the metallic fluoride becomes a fluoride donor, and the XeF6 can accept the fluoride from it to form XeF7 1 minus complex. फ्लोराइड एक्सेप्टर और फ्लोराइड डोनर का कॉन्सेप्ट देखो एनसीईआरटी में दिया हुआ है, नोट्स में भी. ठीक है, तो पहला वाला रिएक्शन जो है XeO3 with 6HF, मीनिंग xenon का ट्राई ऑक्साइड is not decomposed or reaction with HF is not possible. तो जो रिएक्शन आपको नोन है वो फिजिबल है, जो नहीं नोन है वो फिजिबल नहीं होंगे. The brown ring test of nitrate depends on. The brown ring test was the test for which ions? Hello, hello,
Nitrate.
nitrate. And this nitrate ions in the acidic medium was added with freshly prepared ferrous sulfate solution. And then when you add drop by drop the acid solution to it, nitrate is reduced to nitric oxide, ferrous is oxidized to ferric, and H plus is converted to water. Now you have Fe ka complex as FeH2O6, which reacts with the NO, and ligand displacement reaction होकर यहाँ पर आपको मिलता है FeH2O5 with NO. And this complex में Fe and NO both have an oxidation state of +1. ये हो गया ब्राउन रिंग टेस्ट का सारा important details. So it's reduction of nitrate to nitric oxide. The species having a permanent dipole moment. Permanent dipole moment. How do you answer this?
The electronegativities.
Okay, but that is not the only thing to be considered. क्योंकि सब में इलेक्ट्रोनेगेटिविटी का डिफरेंस तो है.
Structure.
हाँ, तो डाइपोल मोमेंट मतलब परमानेंट डाइपोल मोमेंट स्ट्रक्चरली आप देख सकते हो कि उसके वेक्टर्स इक्वल एंड ऑपोजिट अगर होंगे तो दे विल कैंसल ऑफ, एंड दो द बॉन्ड इज पोलर बट द ओवरऑल डाइपोल मोमेंट ऑफ दैट स्पीशीज और मॉलिक्यूल वुड बी जीरो. उसके लिए स्ट्रक्चर के बिना आप नहीं कर पाओगे. कैन यू हेल्प मी विद द SF4 स्ट्रक्चर? टेल मी इन टर्म्स ऑफ BP and LP quick.
4 VPs, 1 NP.
4 BP, 1 LP, so it will be sp3d, and with sp3d it has what type of arrangement?
Trigonal bipyramidal.
Trigonal bipyramid is the geometry. Shape क्या होगा?
Seesaw.
Seesaw shape. Shape will be seesaw. And the lone pair will be present in what position?
Equatorial.
Equatorial position. That's how we draw the structure. तो यहाँ पर will it have the dipole moment? Is it getting cancelled? नो। लेकिन बाकी मॉलिक्यूल्स में अगर आप देखोगे तो SiF4 is a tetrahedral arrangement in which all the dipoles are equal and opposite. They will cancel off each other because of a symmetry in the molecule. BF3 maybe there is a planar arrangement of 3 fluorine atoms and it doesn't have a lone pair. So here also the dipoles will cancel off. XCF4 has a square planar arrangement. So within the plane, all the XCF bonds will cancel off and there will be 2 lone pairs above and below the xenon. तो sp3d2 but square planar. तो ये तीनों मॉलिक्यूल में डाइपोल्स कैंसल ऑफ हो रहे हैं, ए में नहीं होगा. दैट इज व्हाई ए विल हैव अ परमानेंट डाइपोल मोमेंट. क्लियर? सी अप्रोच आपको ध्यान रखना है कि डाइपोल मोमेंट के रिलेटेड क्वेश्चन आया तो हाइब्रिडाइजेशन के बेसिस पे उसका स्ट्रक्चर आइडेंटिफाई करो. एंड इफ देयर इज अ सिमेट्री इन द अरेंजमेंट, the dipoles will be equal and opposite, they will cancel off and it will have a zero dipole moment. Permanent का मतलब the dipole moment mu is non-zero. Non-zero होना चाहिए, it should not cancel off. C4O10 has dash bridging oxygen atoms and dash pi bonds. P4O10 का स्ट्रक्चर कैसा था? How do you start drawing that?
4 phosphorus,
4 phosphorus,
then POP linkages,
then the pop linkages in the circumference and
2 in the center.
between the internal phosphorus atoms also we have the pop linkages and
Double bond oxygens on the
each
phosphorus.
phosphorus bonded to oxygen by a double bond. And after drawing the structure, you know how many bridging oxygen and how many pi bonds are there. Yes. 6 POP bonds हैं और 4 pi bonds हैं. The sequence that correctly represents the increasing order of bond angles in OF2, OCl2, ClO2 and H2O is. This I have discussed in the regular sessions also. और इसका जो order है वो काफी important भी था.
C.
And the correct answer is C. And here are the 4 shapes for the molecules. यहाँ पर फंडा क्या था कि OF2 के केस में fluorine is more electronegative, so it will attract the electron density towards itself. So the electron density on the central atom will decrease. That's why bond angle यहाँ पर सबसे कम हो जाता है. वैसे ही OCl के केस में भी इलेक्ट्रॉन डेंसिटी क्लोरीन की तरफ अट्रैक्ट होता है, लेकिन इट इज नॉट डिक्रीज्ड मोर एज कंपेयर्ड विद OF2. इसलिए OCl2 का बॉन्ड एंगल OF2 से बड़ा है. H2O के केस में हाइड्रोजन का इलेक्ट्रोनेगेटिविटी is very less, so the electron density is more concentrated at the oxygen atom, and that's why it has a bond angle greater than F2O. And ClO2 के केस में it is much more than all the others because the 2 pi bonds which are formed have the electron repulsions between them, due to which the angle would be highest. तो क्लोरीन का डाइऑक्साइड का एंगल 118 के आसपास होता है. Yes, Mahir?
My mistake, sir.
Which of the following order about nitrogen family is incorrect? Group 15 nitrogen family का कौन सा order incorrect है? Order of melting point, is this order correct?
Yes.
Yes. Melting point के लिए the statement was that as we go down the group, the melting point increases up to. The melting point for the group 15 elements increases up to
Arsenic.
Arsenic, and then again decreases, मतलब highest melting point arsenic का होता है, followed by antimony, bismuth, and then going back we have phosphorus and nitrogen. This is indeed the correct order. Order of boiling point of the hydrides.
Correct.
करेक्ट, बिकॉज अमोनिया के लिए जो H बॉन्ड्स बनता है वो BiH3 और SbH3 के कंपैरिजन में वीकर होता है. इनफैक्ट बिकॉज ऑफ द लार्ज सरफेस एरिया, BiH3 and SbH3 का वेंडर वॉल्स आर सो वेरी स्ट्रॉन्ग that it even dominates the stronger H bond, and that's why the boiling point order was exceptional. It was bismuth, antimony, ammonia, then arsine and phosphine. Order of boiling point. Now, the boiling point depends on the molar mass and the intermolecular forces. So, in general, the boiling point down the group goes on
Increasing.
increasing. But in case of group 15, it was increasing, but antimony and bismuth में there was a slight difference. एंड ऑब्जर्वेशन ये था कि एंटीमनी का बॉइलिंग पॉइंट सबसे हाईएस्ट होता है, बाद में बिस्मथ का, एंड देन एज एक्सपेक्टेड. मतलब इस ऑर्डर में गड़बड़ है. द करेक्ट ऑर्डर शुड हैव बीन लाइक दिस. एंड डेफिनेटली लास्ट ऑप्शन करेक्ट होना चाहिए. एसिडिक स्ट्रेंथ में नाइट्रोजन, फॉस्फोरस, आर्सेनिक एंड बिस्मथ, मोर द एसिडिक नेचर, मोर विल बी द इलेक्ट्रोनेगेटिविटी. मतलब किसी भी ग्रुप में ऑक्साइड में सेंट्रल एटम इफ इट इज मोर इलेक्ट्रोनेगेटिव, इट विल बी मोर एसिडिक. सो एसिडिक स्ट्रेंथ डाउन द ग्रुप डिक्रीजेस एंड द बेसिक स्ट्रेंथ इंक्रीजेस. तो ये ऑर्डर करेक्ट है. सो द आंसर इज ऑप्शन सी. मेल्टिंग पॉइंट एंड बॉइलिंग पॉइंट ऑफ ग्रुप 15 वेरी इंपॉर्टेंट, एंड इन दैट आई हैव आल्सो कवर्ड ऑक्साइड्स एंड हाइड्राइड्स का पार्ट. आइडेंटिफाई द इनकरेक्ट रिएक्शन. Ammonium chloride with sodium nitrite releases N2. Is it correct?
Yes.
Yes, ये नाइट्रोजन का लेबोरेटरी प्रिपरेशन है. अमोनियम क्लोराइड विथ नैनो 2. Then ammonium का डाइक्रोमेट on heating gives N2 gas.
Yes.
Correct.
Yes. अमोनियम के रिलेटेड बहुत सारे इंपॉर्टेंट रिएक्शंस है. जैसे अमोनियम का नाइट्राइट को अगर हीट करो तो क्या मिलता है? नाइट्राइट.
Nitrogen gas.
एंड नाइट्रेट
N2O.
N2O. Perfect. Ammonium chloride with calcium hydroxide gives ammonia.
Yes.
Yes. तो ये तीनों अगर करेक्ट रिएक्शन है तो आंसर होगा डी. What is the problem with the D reaction? How is HNO3 prepared?
With the nitrate.
With the nitrate. तो यहाँ पर 3 होना चाहिए, then this reaction would have been correct. Niter or nitrate with the H2SO4 gives bisulfate, and HNO3 is prepared on a small scale, meaning this was a laboratory preparation, but it shouldn't have been nitrite, it should have been nitrate. Which of the following order about group 16 family is incorrect? First one, electron gain enthalpy, is it correct?
Yes.
Yes. Sulfur has the highest electron gain enthalpy for the group 16, followed by not oxygen. It is selenium, tellurium, polonium, and oxygen is at the end. Oxygen ka electron gain enthalpy is the lowest among the group 16 family. This is as per the values the order is identified. sulfur, selenium, tellurium, polonium, and then oxygen. Stability of hexahalides. Fluoride is more stable than fluoride, bromide, iodide. Is it correct? अभी एक
Yes.
फंडा भी बताया था, छोटे एलिमेंट के साथ मल्टीपल हैलोजेंस लाइक फ्लोरीन होल्ड करना पॉसिबल है, लेकिन क्लोरीन, ब्रोमीन, आयोडीन जैसे साइज बढ़ेगा वो होल्ड करना डिफिकल्ट हो जाएगा। ये सिलिकॉन के लिए बताया था। तो द स्टेटमेंट इज सल्फर का हेक्सा फ्लोराइड इज एक्सेप्शनली स्टेबल and the other hexahalide do not exist. So this is correct order. Acidic character of hydrides. Is this correct?
No.
No. Hydrides के केस में जो properties था, I summarized it as SAR. The stability of hydrides decreases. Acidic strength increases. Reducing power increases. यहीं पे मैंने ड्रैगोज रूल भी बताया था, जो बॉन्ड एंगल और बेसिक नेचर को रिलेट करता है। तो बॉन्ड एंगल की अगर बात करें तो H2O के केस में हाइब्रिडाइजेशन होता है एंड द एंगल इज मैक्सिमम. Down the group, the angle is somewhere around 90 degree because of the Drago's rule. So acidic strength increase होता है. H2P should have been the strongest acid and this order is incorrect. तो ये वाला ऑर्डर करेक्ट होगा. समझा?
Yes, sir.
Which is not valid for oxo acids of phosphorus. All oxo acids contain tetrahedral sp3 hybridized phosphorus.
Yes.
It does. All contain at least one P double bond O and one POH.
Yes.
Yes. Orthophosphoric acid is used in the manufacture of triple superphosphate. What is the formula of superphosphate of lime used as a fertilizer?
CaH2PO2
Right?
H2PO, yeah, H2PO2 twice.
Was it H2PO2 or H2PO4? Superphosphate of lime.
PO4.
PO4 का मतलब it is a derivative of which acid? Orthophosphoric acid ना? तभी तो बोला है
Yes, sir.
orthophosphoric acid is used in the manufacture of triple phosphate. Yes, it is. In fact, इसका complete formula था CaH2PO4 twice dot 2H2O and there was addition of gypsum CaSO4 dot twice H2. So derivative of phosphoric acid and gypsum का addition gives you superphosphate of lime. Hypophosphorus acid is a diprotic acid. No, it's a monoprotic acid. यही आपका आंसर है. Which of the following order correctly represents the increasing order of acids? These are the oxy acids of chlorine. Chlorine, which was the strongest?
Perchloric.
Perchloric, then chloric, then chlorus, and then hypochlorous. And these are the formulas, which is HClO4, HClO3, HClO2 and HOCl. और ये जो लिखने का तरीका है वो स्ट्रक्चर को भी रिलेट कर देता है. जैसे अगर आप यहाँ पे ड्रॉ करोगे तो इट विल हैव HOCl, डबल बॉन्ड O, डबल बॉन्ड O, डबल बॉन्ड O. यहाँ पर इसका रेजोनेंस स्ट्रक्चर जब देखेंगे तो यहाँ पर when the H plus is released and we get the perchlorate anion, it will have all the pi bonds distributed equally among the chlorine oxygen bonds. That's why the bond order was calculated as
1.75.
बोलो भाई 1 sigma plus 3 by 4, 7 by 4 was the bond order equal to 1.75. एंड हाइब्रिडाइजेशन अगर पूछा तो सारे क्लोरीन में sp3 हाइब्रिडाइजेशन है। ठीक है, यहां पर मैंने एक और चीज बताया था SAID। व्हाट वाज दिस?
Stability.
स्टेबिलिटी इंक्रीजेस SI
OD.
हाँ SIOD सॉरी। Stability increases and oxidizing power decreases as the oxidation number increases from +1 to +7। तो ये दो ऑर्डर यहाँ पर क्लियर हो जाते हैं। ऑक्सीडेशन स्टेट्स 1 3 5 7 के फॉर्म में होता है एंड स्टेबिलिटी बढ़ती है, ऑक्सीडाइजिंग पावर कम होता है। ठीक है, XeF2 is isostructural with मतलब having the same structure। तो पहले तो XeF2 का स्ट्रक्चर में there will be 2 BPs and remaining 6 electron will have 3 LPs which is equal to sp3d and with 3 lone pairs it will have a linear shape। तो linear shape और किसका होता है? Yes, linear shape और किसका होता है? If you look at the first option, ICl2 negative is nothing but equivalent to the polyhalide I3 negative, and the 3 iodines were placed in the linear arrangement with this iodine containing the 3 lone pairs। Central atom जो है वो sp3d hybridized है with 2 bps 3 lps and it is isostructural with XeF2, which is not correct or which does not give the correct picture of the trends indicated against it। और ये group 17 के related है। Is the first one correct?
Yes.
Yes. Chlorine has the highest electron gain enthalpy followed by fluorine, bromine, iodine। Second one.
Wrong.
What should be the correct order for BD?
Chlorine, bromine, fluorine, iodine.
Very good. Chlorine, bromine, then comes third position पे fluorine and then iodine। F2 has a very low BDE। Then electronegativity order is down the group decreasing, correct? And oxidizing power is also decreasing। Now, what was the factor which confirms or justifies that F2 is a very strong oxidizing agent?
Hydration enthalpy.
High hydration enthalpy, delta H, HYD, and also very high value of standard reduction potential। So because of very high SRP, it has a tendency to undergo reduction and will behave as a very good oxidizing agent। That's it. With this, I was able to cover the important parts of the P block elements, though obviously it is not possible to revise the entire chapter in one shot, but जितने भी important concepts या जहां पर MCQs पूछे जा सकते हैं, the important topics that I have covered। So now you know that which topics you are supposed to focus more on। मतलब trends के ऊपर focus करना है, exceptions के ऊपर focus करना है, कौन से reactions correct है, कौन से नहीं है, oxy acid structure, hybridization, bond angle, the acidic strength, the various orders related with hydrides. These are the various sections you have to cover properly. बाकी रिएक्शन रिलेटेड क्वेश्चंस इतने ज्यादा पी ब्लॉक में से नहीं आए हैं इन द नीट एग्जामिनेशन. Mainly the questions are with respect to the trends, the oxidation states, the structures, hybridization related, bond angle order, bond order के related questions. ठीक है, तो इस पे ज्यादा फोकस हुआ है क्वेश्चंस. अगर प्रीवियस ईयर क्वेश्चंस आप देखोगे, you will have a better idea about it. ठीक है, so prepare the chapter accordingly कि कौन से टॉपिक से ज्यादातर क्वेश्चंस आए हैं और किस तरह से पूछे गए हैं. If you know this, if you are able to understand this, it will be easier for you to revise the chapter. Fine?
Yes.
Yes.
Chalo. Thank you.
Thank you.
Thank you.
Yes, sir.
Thank you, sir.